You can do this experiment from Celestia. At the end, we will get the gravitational constant value G, and we will get the value for the mass of Jupiter. We will use the Kepler's law. I will give you the entire theory. I will give you the entire demonstration. So when you start Celestia, Celestia, on your computer, it can work even on your mobile phone. I have shared that. First of all, you go to Jupiter. Okay, so go to solar system browser, go to Jupiter. Jupiter, click Jupiter, and then say go to. Okay, click Jupiter and then say go to. So we end up in getting Jupiter. So this is our Jupiter. Now what you do is that we will focus on 4 satellites of Jupiter. One is Io, the second one is Europa, then it is Ganymede, then it is Callisto. Okay, there are other satellites, but we'll not bother about it. I've told you earlier that Galileo was the first astronomer to observe these 4 satellites. So we call them as the Galilean satellites. So once you get this thing, with your mouse, you can turn these things like this. What you do is that go to render, go to view options. Okay, in this view options, please click only these 4 things. Number 1, click orbits, because we want to see the orbits of these satellites around Jupiter. Okay, click these orbits. So I have ticked this thing already, tick it. The second thing is tick planets here, because we want to see Jupiter as a planet. So there should be tick in orbit, there should be tick in planets, and here show planets. Okay, so there should be a tick here. Then there should be a tick in moons. There should be 2 ticks in moon, 2 ticks in planet, 1 tick in planets, the other tick in orbit. Okay, of course you are getting this video, so don't worry. I hope that things will not go bad. Anyway, by the way, I take a print screen. So let me take that. So I've taken a print screen. In case the entire video system collapse, at least I will be able to share these things. Okay. So now once you have done this, say okay. Again, I repeat, go to render, go to view options. These 4 things should be ticked. Now what I do is that with my mouse, I change the orientation. So this is the plane of the orbit of satellites. So the satellites are going around Jupiter in these planes. Now I orient it like this. Okay, I can do zooming. Okay, I de-zoom it. Okay, so now I can see these satellites. Okay, so you have these orbits of these satellites. Ignore Amalthea, that is not required. In case you want to do it, it's a separate thing. It is up to you. But focused on Io, Europa, Ganymede, Callisto. Okay, I have discussed about these satellites. So these satellites are going around Jupiter, all in the same plane and in the same direction. Okay, in fact, if I go to time, say 10 times faster, now they are going 10 times faster. Let me increase the speed. Now you see the satellites are going around Jupiter. Okay, Galileo was the first person to observe these satellites going around Jupiter. Now what we will do is that in this exercise, the practical, we are going to measure the periodicity of these satellites as they go around Jupiter. See, the time is coming here. If you go to the right hand side, top side, time is coming here. Okay, we will measure the periodicity of these satellites. Now we will measure the orbital distance, the orbital radius. Okay, I will tell you how to do that thing. Once we get both the informations, we will be able to calculate the value of the mass of Jupiter using the Kepler's law. The same law we will use to calculate the gravitational constant, G. Okay, so these are the 2 things which we are going to do. There is a third experiment. Let us not bother about it. We can actually calculate the velocity of light also using this experiment. So at least two things we will be able to cover up. Okay. So this is what you have to do. Generally, when you do this thing, you will get this plane. But using your mouse, you can change the orientation. Make sure it is perpendicular. You are sitting on the perpendicular of the plane of the satellite. Now, what you do is that you go to time, you say real time. So you will get the real time. Okay. Now let me do that thing. Set time. Let me set time. Set. Okay. So let me repeat it again. Go to time. Say set time. You can set any time whatever you want from here. Okay. You want to do some 1,000 years from now. Let us see. Can we do that? Let us do that. 3021 means if you are living, let us say, on 7th of May 3021, this would be the configuration. Okay. So let us go to the present. So go to set to the current time. Say okay. Okay, now we are comfortable. So go to the right hand side. You can read the date. You can read the time also. So it is 26th of April 2021. Time is 3:14. Okay, 3 past 14. Okay, so this is the present configuration. Now what I do is that if you are familiar with print screen, how does the print screen work on a typical laptop? There is a window button. You press the window button along with the print screen button. Okay. So like this, for instance, I click. So this file is now saved. Okay. Into where is it saved? If you go to the pictures window, there is a picture window in your laptop or computer. So there is a screenshot window, something like that. So it is automatically saved there. Okay. If you want to save this file, it is okay. But what you can do is that now with this red as a line axis, okay, you can measure the distance. Simply put a scale on top of it. Okay, with center at the center of the Jupiter. Please don't use the zoom button again. Please do not use the zoom button again. Okay, because otherwise the whole context is lost. So with Jupiter as the center, first of all, see what is the size of Jupiter itself with that scale. It would be something like 6-7 millimeter. Just put the screen on your laptop screen. Okay, measure the distance from the Io to the center of Jupiter, then Europa to the center of Jupiter, Ganymede to the center of Jupiter, Callisto using the to the center of Jupiter. So you will get the basic orbital parameter, and that is the distance of this satellite from the center of Jupiter. Okay, and I have already told you to measure the distance of measure the radius of Jupiter. Okay, so it would be few millimeter. While doing all this thing, please do not change the focusing. Sorry, please do not change the zoom button. Do not play with the zoom button. Okay. Now, once you have done that, you know how much is the distance of Io from the center of Jupiter in terms of centimeters. How much Europa is from the center of Jupiter in terms of centimeter, Ganymede and Callisto. And you have already measured the radius of Jupiter, few millimeters. Now that few millimeters of Jupiter correspond to 70,000 kilometer. The actual radius of Jupiter is 70,000 kilometer. So if few millimeters correspond to 70,000 kilometer, so you will know the exact distance of Io from the center of Jupiter in kilometers, Europa in kilometers, Ganymede in kilometers, Callisto in kilometer. So one part of the problem is solved. We have measured the distance of all these satellites from the center of Jupiter in kilometers. We are not used the data. Please keep this thing in mind. We have not used the data generated by planetary satellites. Okay, we have simply normalized the distances of these orbits in terms of the size of Jupiter. And the size of Jupiter is 70,000 kilometer, 70,000 किलोमीटर. ठीक है, तो वो दैट 70,000 किलोमीटर कॉरस्पॉन्ड्स टू फ्यू मिलीमीटर. तो पूरा आप एक इसके ऊपर स्केल रखो, स्केल आपको डिस्टेंस बता देगा, वो सेंटीमीटर्स को आप किलोमीटर में कन्वर्ट हो जाएंगे. सो यू गेट द डिस्टेंस ऑफ दिस. इस हमारे पास पहली चीज आ गई, दैट इज द डिस्टेंस ऑफ दिस सैटेलाइट फ्रॉम द सेंटर ऑफ जुपिटर. अब हम क्या करेंगे, वी गो टू दिस टाइम अगेन. Now what we will do is that we go to, let us say, set time. Okay, so right now the time is 26 April 1518. That is the time. Now you click on this 26, write 27. Okay, say okay. Now this is the configuration on 27th of April 2021. You see that the satellites have changed. Satellites have changed. Now what you do is that you keep on measuring the position of the satellites. Okay, so what you can do is that either you can put a simple D here. Okay, this is the reference line. You put a D. Okay, you have a, in your geometry box you will have the D. You measure the angle. For instance, IO is right now at something like 90. It's between 90 and 180 degrees, somewhere halfway through. Callisto is something like 60 degrees. Okay, so you keep on monitoring these angles. So on 26th April, what was the angle for these satellites? On 27th April, what is the angle? Monitor that. Then again go to set time. Right here, 28th of April. Say okay. Now this is 28th of April. You see that the satellites have changed. Europa is at 0 degree angle. Io is at 180 degree. Ganymede is 180 degree. Callisto is at almost like 90 degree, something like 85 degrees. You can simply put a D with the center of the D at the center of Jupiter. Just simply measure the angles. Keep on taking these readings. Okay, keep on taking these readings for, let us say that you do it for 10 days. Okay, it's hardly any exercise. Or you do it for 15 days. The more the data you will have, the better would be your answer. So based on this experiment, if you follow now Callisto, for instance, you will see that the Callisto is changing. It is moving. All the satellites are going. Okay, they are going around the Jupiter, and what you do is that you measure their periodicity. In 15 days of observation, if you, let us say, do it for 15 times, you will get the idea about the periodicity of the satellite. So you have done two things. One is that you have normalized the distance of every satellite with respect to the size of Jupiter. So this way you have estimated the orbital radius of a satellite. Okay, you have not used any data. Please keep that thing in mind. Other than that, you have used a D. So you need a scale and a D. Just put it on the screen and do it. If you want to be more precise, take this image, take this screenshot for every day. So you will have 10 or 15 screenshots available. So you will have those screenshots available. So you can do very peacefully on with a D and a scale. See, generally when we do it with our telescope, we measure these things with our telescope, with the proper softwares. Then we take printouts. But at this moment, I cannot ask you to go to market and get printouts. It is dangerous. So get these screenshots, measure the distances. As far as the distances are concerned, once you have calculated the orbit, it is done forever. So you have to simply measure the angles of all these 4 satellites individually. You will get the periodicity. Okay. So now let me explain this theory a little bit, then I will come back to this again. Okay, so the first thing is that you go to, let me show you this thing. So here in this, what you see is this 4 satellites. Let me circle them: Io, Europa, Ganymede, Callisto. So this is 1, 2, 3, 4. Okay. So now again I repeat that measure the distance of every satellite from the center of the Jupiter by putting a scale on this figure. So you take a scale, simple scale, एक फुटा ले लो, सेंटीमीटर मिलीमीटर वाला. जुपिटर का साइज जो है वो है 70,000 किलोमीटर. मैं बार बार रिपीट कर रहा हूं ताकि कोई डाउट ना हो आपको करने में. 70,000 किलोमीटर वो पता है. बाकी के जुपिटर का इधर होगा 3-4 मिलीमीटर. ठीक है. तो बाकी के सारे डिस्टेंसेस को कैलकुलेट करो. देन यू पुट ए डी हियर ऑन दिस. एक डी रख दो ऐसे करके. इसको सेंटर पे रखो जुपिटर को. सारे सैटेलाइट्स के एंगल कैलकुलेट करते रहो. ठीक है. ये है 29 अप्रैल को. हर एक दिन बाद करते रहो. ये नहीं मतलब एक दिन आज कर लिया, एक दिन कल करा, ऐसे नहीं. सॉफ्टवेयर आपको उसी टाइम कर देगा. इट विल डू इट एट द सेम टाइम. It is hardly going to take you half an hour to do this thing if you do it very carefully. अगर ज्यादा दिन की जरूरत पड़ेगी, एरर आ रहा तो ज्यादा दिन करते रहना. 15 दिन कर लेना. जो 15 दिन है सिमुलेशन टाइम, इसको हम कहते हैं सिमुलेशन टाइम. 15 days ऑफ सिमुलेशन टाइम, नॉट दी एक्चुअल टाइम. एक्चुअल टाइम तो हमारे को करने में 10 मिनट 15 मिनट लगेंगे. लेकिन ये हम किसी टाइम पे वो उससे करते होते थे, टेलीस्कोप से प्रिंट वगैरह लेके. अब प्रिंट मत लेना, स्क्रीनशॉट आप ले सकते हो. और एक फोल्डर बना लो, स्क्रीनशॉट ले लो आज की डेट के, कल की डेट के, परसों के, ऐसे ऐसे करके. और स्क्रीनशॉट्स पे फिर आप आराम से करते रहो. कोई लेकिन नो जूमिंग, जूम नहीं करना ना. इंक्रीज जूमिंग या डाउन जूमिंग, फिर ये सारा स्केल ही चेंज हो जाएगा. कैलिब्रेशन सारी की सारी चेंज हो जाएगी. वो ध्यान रखना, कैलिब्रेशन मत इसको चेंज करना. ठीक है. सो दिस इज द एक्सपेरिमेंट. अब ये थ्योरी है, थोड़ी सी सिंपल थ्योरी है, यू नो इट ऑलरेडी. एक सपोज करो एक मास m है. ठीक है. सेंट्रल बॉडी m है. एक स्मॉल मास है m. ये इसके ऑर्बिट में जा रहा है. ठीक है. अब डिस्टेंस है बिटवीन देम इज a. ठीक है. इसको हम सेमी मेजर एक्सिस कह देते हैं. अब थ्योरी क्या कहती है हमारे को, ये मैंने सिंपली विकिपीडिया से लिया है क्योंकि ये आपको बिल्कुल अवेलेबल है. आप केप्लर्स ला के विकिपीडिया में चले जाओ. ये मैंने वहीं से उठाया सिंपली. ठीक है. क्योंकि ये सीधी सी चीज अवेलेबल है. तो ये पता आपको रूल, सेंट्रीपिटल फोर्स वो ग्रेविटेशनल फोर्स से इक्वेट करता है. फाइनल हमारे पास जो आंसर आता है वो आता है ये. ठीक है. इसमें t इज दी टाइम पीरियड. टाइम पीरियड मतलब एक सर्कल करने को, ये जो स्मॉल m है, ये कैपिटल M के एक सर्कल करने में कितना टाइम लगता है. सो दैट इज टाइम पीरियड. ठीक है. वो टाइम पीरियड आ गया. a जो है, a है डिस्टेंस बिटवीन द टू ऑब्जेक्ट्स. इसको हम सेमी मेजर एक्सिस कह सकते हैं. कर करा के बात ये बनती है कि दिस a raised to the power 3 upon t raised to the power 2 is equal to approximately gm upon 4 pi r square, 4 pi square सॉरी. ठीक है. ये जो रिलेशन है, इस रिलेशन को हम कहते हैं केप्लर्स थर्ड लॉ. सो दिस इज केप्लर्स थर्ड लॉ. ठीक है. अब एक इंटरेस्टिंग चीज देखो, विकिपीडिया ने इन्होंने कैलकुलेट करा हुआ है. ये जो चीज है ये डिपेंड करती है आपकी ग्रेविटी पे और आपके मास पे. ठीक है. तो आपके पास अगर आप सन का केस लो, मींस इफ m इज योर कॉरस्पॉन्ड टू द मास ऑफ द सन. ठीक है. और फिर आप मरकरी का लो, तो दिस r क्यूब रेज़ टू द पावर t स्क्वायर, ये जो वैल्यू है ये इतनी आती है. चाहे मरकरी हो, चाहे वीनस हो, चाहे अर्थ हो, मार्स हो, जुपिटर, सैटर्न, सबकी एक वैल्यू आएगी. तो दिस इज केप्लर्स लॉ. ये केप्लर ने एक्चुअल यूज करा था. जब केप्लर का एक्चुअल डाटा है, ये केप्लर ने करा था. केप्लर ने भी यही चीजें टेक्निक यूज करी थी जो हम कर रहे हैं. जो हम बेसिकली कर रहे हैं, इसमें हम वही चीज रिपीट कर रहे हैं जो केप्लर ने 400 साल पहले करी थी. दिस इज 400 years फ्रॉम द पास्ट टाइम। अब मैं एक इंटरेस्टिंग छोटी सी स्टोरी बता देता हूं ताकि चीजें इंटरेस्टिंग लगे। एक बंदा होता था, उसका नाम था टाइको ब्राहे। ठीक है, टाइको ब्राहे वाज एन एस्ट्रोनॉमर। So this Tycho Brahe collected lot of data based on the motion of planets। ठीक है, टाइको ब्राहे को एक बंदा चाहिए था, असिस्टेंट, जो उस डाटा का मैथमेटिकल इंटरप्रिटेशन कर सके, एनालिसिस कर सके। So Tycho Brahe took Kepler as his assistant। So Kepler was the assistant of Tycho Brahe। केपलर ने उसका सारा डाटा लिया, टाइको ब्राहे का, सारी मोशन सैटेलाइट्स वगैरह का, प्लैनेट्स की मोशन का। बेस्ड ऑन इट ही डिड्यूस दीज लॉज, जो हम जिनको कहते हैं केपलर्स 3 लॉ। ठीक है, आप देख सकते हो रिवीजन के लिए, वो आप इंटरनेट में सब कुछ अवेलेबल है। ठीक है, ये एक छोटी सी स्टोरी है। इंपॉर्टेंट चीज ये है, अगर आप नोट करो यहां पर, okay, let me select this। okay, if you note here, this number is not changing। why it is not changing? Because it deals with the mass of the sun and the gravitational constant। वो ग्रेविटेशनल कांस्टेंट तो वैसे कांस्टेंट है, मास ऑफ सन भी सबके लिए तो सेम ही सन है, सब ये प्लैनेट सन के आसपास ही तो जा रहे हैं। ठीक है, तो अगर हम इस रिलेशन से जी की वैल्यू को फिक्स कर दें, it is anyway constant, so we will get to know about the mass of the sun। तो आप बड़े एक सिंपल ऑब्जर्वेशन से ही सन का मास कैलकुलेट कर सकते हो। अगर आप लोगों के माइंड में ये कभी डाउट आया होगा कि सन का मास कैसे कैलकुलेट करते हो, सो दिस इज हाउ यू डू इट। अब हमारी प्रॉब्लम में व्हाट वी हैव हियर इज दैट वी हैव द मास ऑफ जुपिटर, दैट इज व्हाट वी आर सपोज्ड टू कैलकुलेट। तो हम क्या करेंगे, हम अपने जो भी हमारे 4 सैटेलाइट्स हैं, ठीक है, लेट मी गो टू द नेक्स्ट वन। ये हमारे 4 सैटेलाइट्स हैं। ठीक है, मैंने ये इनका टेबल ले लिया ताकि आपको ठीक लगे। ये भी मैंने विकिपीडिया से लिया। तो दिस इज आयो, यूरोपा, गैनेमिडी, कैलेस्टो। गैनेमिडी इज द लार्जेस्ट सैटेलाइट इन अवर सोलर सिस्टम। अब इनके जो सेमी मेजर एक्सिस या जो डिस्टेंस है वो आर है। तो जब आप कैलकुलेट करते हो डिस्टेंस ऑफ ए सैटेलाइट फ्रॉम द सेंटर ऑफ जुपिटर, आप देखो कि आपका एरर कितना आया। दीज आर स्टैंडर्ड वैल्यूज, इससे आप परसेंटेज एरर कैलकुलेट कर सकते हो। ठीक है, तो पहली एक्सरसाइज तो वही हो गई, तो इसका वो आप निकालो कि आपका एरर कितना आया। ठीक है, दूसरी चीज, आप ऑर्बिटल पीरियड जब निकालोगे तो ये दिस इज इन डेज, अर्थ के डेज जो होते हैं। ठीक है, अर्थ के डेज में आप कैलकुलेट कर दो, तो आपका जो ऑर्बिटल पीरियड आता है, यू कंपेयर इट विद दिस। ठीक है, फॉर इंस्टेंस दिस इज 7, दिस इज 16। ठीक है, वो ऑर्बिटल ये डेज में है, ये दिस इज इन डेज। ओके, ये ठीक है, तो अब फिर देखो आपकी परसेंटेज एरर इनमें कितना है, चारों में। ठीक है, तो आपके पास 4 डेटा पॉइंट्स ऑलरेडी हो गए डिस्टेंस के, उनको आप कंपेयर करो इन स्टैंडर्ड वैल्यू से, दिस इज इन किलोमीटर। जो आपके ऑर्बिटल पीरियड हो गए वो आप कैलकुलेट करें, वो इससे कंपेयर करो, वो भी एरर आ जाएगा। जब ये चारों डाटा आ जाए, अब वो जो रिलेशन है, दैट रिलेशन इज फिक्स्ड। ठीक है, वो रिलेशन क्या कहता है, जो आपकी आर की वैल्यू और जो टी की वैल्यू है वो डिफाइन करेगी जी और एम की वैल्यू। तो आप क्या करो, आयो और यूरोपा का जो डाटा है, आप जी को कांस्टेंट अज्यूम करके एम की वैल्यू कैलकुलेट कर दो। तो दिस इज मास ऑफ जुपिटर, इसको कैलकुलेट कर दो आयो और यूरोपा के डाटा से। ठीक है, तो आपकी जुपिटर की वैल्यू आ गई। इसमें हमने अज्यूम करा कि जी की वैल्यू हमारे को नोन है। ठीक है, फिर आप क्या करो, सेकंड सेट ऑफ प्रॉब्लम में आर और टी तो फिक्स करके आप अब एम जे जो आपने कैलकुलेट करा है, मास ऑफ जुपिटर जो कैलकुलेट करा है, उसको वो मान के अब जी की वैल्यू को कैलकुलेट करो, और इसके लिए आप कैलेस्ट्रो और गैनेमिडी का डाटा यूज करो। ओके, सो द मॉरल ऑफ द स्टोरी इज दैट you have 4 satellites, you use the data of 2 satellites to calculate the mass of Jupiter assuming the G value, the standard G value. Then you take the Ganymede and the Callisto satellite data to calculate the G value by fixing the value of mj what you have obtained from here. तो कर करा के कहानी ये बनती है कि you can calculate two important things. One is the gravitational constant G and the mass of the Jupiter by doing this particular exercise. Okay, let me recapitulate the whole thing. It's a quick recapitulation. You go to that software, okay, which is already opened, I think somewhere downstairs. Okay, you first of all, you measure the distances of these satellites in terms of the radius of Jupiter. Radius of Jupiter is 7,000 kilometers. Okay, so you will know the exact distances of every satellite from the center of Jupiter. Compare it with the data which exists. The problem number one is done. Then you take a D, put it on this line and put this as a center, measure the angles. Don't zoom in or zoom out. Don't do that. Okay. You know the time from here. Do it at a 1 day interval. Take 10-15 days data. So you will come to know about the periodicity of Callisto and all other satellites. Then you have that relation using the data of two satellites, Io and Europa, calculate the value of Jupiter mass by keeping the G constant, then taking the data of Callisto and Europa, wherever it is, by keeping the mj fixed from what you have obtained from here, you calculate G. At the end, you will have the value of G, calculate the percentage error with respect to the actual value. For the Jupiter mass, calculate the percentage error. You will get the data from internet. So you will have 5 or 6 readings. Okay. This is the most simplest thing which can be thought about. Let me get out of this thing because there is nothing left here. Now, again, I go back to this software. When you start working on it, you will have it like this. Change the orientation. Once this orientation is changed, don't zoom in or zoom out. Go to time, set time, keep on changing the time to the next day. Okay, like 29th. Okay, so these satellites will move. Measure the distances using a scale by putting it between the two things. Okay, normalizing it with the radius of Jupiter. Take a D, measure the angles on different days. Make a table. You will get everything. Okay. So as far as this experiment is concerned, this is over. Now, what I do is that in case some of you are interested in going into more interesting softwares which will deal with this. See, as far as your experiment is concerned, it is over. Okay, that is over here. But in case somebody wants to go into more interesting details, so let me show you what to do for that. Okay, so for that, what you do is that I will take you to a particular site. So write CLEA, CLIA Astronomy. Okay. Now there is a Project CLIA homepage. Sometimes people want to do some projects, they don't get admission in those projects, summer vacation or whatever it is. This is something which you can do at home and you can put it on your CV. Okay. So here on this is the website. Okay. So you can put it like this. This is the website. Now you go to software here. You will see endless list of softwares. For instance, this software deals with how the pulsars radio wave takes place. These are simulations basically. So it is as if you are operating a very powerful telescope and your laptop becomes the console of that telescope. So you will see everything. So it deals with astronomy. There is one here, Revolution of Moons of Jupiter. Okay, you can actually download it, you can run it. There is one important thing. whatever software you want to download here, make sure that you go to the administration login of your computer or laptop. There you install it. It works only that way. It does not work elsewhere. Okay, so make sure that you are installing it as a administrator login of your laptop or computer. There is another here, rotation of Mercury by Doppler effect. There are so many softwares. You can measure the expansion of our universe. You can measure this one, for instance, deal with the Jupiter moons and the speed of light. You can calculate the velocity of light using this software. You can calculate the energy, how the energy is generated inside sun here. You can do the spectroscopy of stars. Maybe I will come to this some time afterwards. So download these softwares. Okay, it's a very long list. You can spend a lot of time on this, and you can write it in your CV that you have done these softwares if you have done. Okay, there are manuals available here. If you click manual, you will get these manuals. So you can read these manuals. You can do these things. Okay. I will show you the demonstration of this one of the software related with the moon. So the important thing is that you have to do it in your login. Sorry, administration login. Okay. Otherwise, it does not work. Okay, so this is the software revolution of Jupiter moon. So when you do it like this, it opens up a window. Just write something here. You are actually supposed to write your name. Then go here, log in. Student number 1, let us say something, you write some name. Okay. Okay. Now you see it will work. Then you go to run. Now it will start running. So I hope you can see it. This is Jupiter. These are the satellites of Jupiter. Okay. If you go to features here, you can say animation, ID, everything. Click everything. Okay. Now you see these orbits. What I've done from Celestia, the same thing is working here. Now if I run, you see, as the time progresses, the time is mentioned here. 28th of April now. Go to next. You see, you can do the same thing here. Put a scale, measure that, everything. But here, Jupiter is out of scale in this software. Please be careful about that. I do not know. Please check it. On that Celestia, it is on to scale. Here again, you can put a reference line, put a D on the screen, measure the angles. If you run it in a continuous mode, you see this. You see this? Ignore this. There is an eclipse. So the satellites are going around. So you can use